True, false. This command provides, true, false question reads, the following command provides the owner of a file called punchbuggy.txt all possible permissions. The group assigned to a file, read and execute permissions, and all others who may access a file, no permissions. Note that you may assume the command is used by a person with proper super user privileges, and it is entered from the correct location in the directory path to perform the command properly. So we're specifying that it is in the right place, and you do have the right permissions to do it, okay? So does this command achieve that purpose?
No.
Why not? What's the problem?
Hold on, cause 750 is,
I'm glad
hold on,
no, I'm glad you're going down this road.
I found a site online that actually does tell you what 750 is, and it tells you what all the numbers are.
Yeah. So 4, 2, and 1, read, write, and execute. When you use the, all right, there's a Linux survival guide, and we've kind of been down this road before, but you
Yeah,
have,
it's called the site was called chmodcommand.com.
yep. What's this command? What is this command right here?
Well, let me type it in. It's not letting me.
Well, you just said it. The site is called what?
CHMOD.
CHMOD. What is this command?
It's a mod.
We're not modifying the
Oh,
security.
okay. Well,
We're, we're modifying the ownership.
Oh yeah, OWN owner. Ha!
Do you see what I'm saying? Now, I mean, okay, sometimes I get a question wrong and we got to back the truck up like we just did with item 1. Yeah, okay. This one, I've had students get really passionate. They're like, no, Kentop, you're wrong. I know it's 750. It is. If the command is chmod, change modification, change mode, however you want to pronounce it. Everybody has their own flavor of pronouncing chmod. Change mode. The reason it doesn't work is because it needs to read chmod. And I'm shocked at the number of students that fell for it, but I bet for the final attempt of your module 3 assessment, no one will fall for it.
I feel like it's gonna be the opposite.
Yeah, it could be. And yeah, we'll have a better question about macros until you get to module 4. And then you'll see this thing. It'll be like, oh, deja vu. I remember seeing this one about macros. Okay, let's make some tracks so we cover the rest of these. The following relational algebra operator is represented by this symbol. Now, this is basically in your addendum or study guide. Which feature in Microsoft Access performs the same function as this RA operator? That is for query, right? When you query records with a filter, the keyword there is to filter for a given criteria. So this RA operator selects for a given criteria. Another way to represent that function is to say it filters. So when you see that, it's filter. Any question? Prevention of garbage in, garbage out. That acronym, garbage in, garbage out, should be familiar if you read the related material. You want to prevent garbage in, garbage out as data elements are collected, for qualitative analysis. So are we dealing with the input part of the table, the output part of the table, or the process in the middle? Input, process, and output table. Which part of the table are we talking about here? Hello? If you're collecting data that goes into a data table,
Input.
it's input, right? Okay, wasn't trying to trick people. Which of the options listed below will help you achieve this simple but essential purpose? Use forms, incorporation of lookup tables for consistency. So what are we saying? If you have a form and then you have lookup tables, people are pulling options to click on, so you get the same exact entry. What was the example we've used in our module? Well, does everybody remember the turtle thing? The turtle?
Yeah.
Okay, that was a lookup table. And the whole idea of having a lookup table is you control what people enter. If they type in green turtle, if they type in green next time, if they type in GRN because they're tired of typing, when you do a search and you analyze, all the inputs are different. In the first case, it's green turtle. In the next case, it's green. And then in the last case, it's GRN, right? So you try to analyze for green turtle and you only find one record. But there are actually three. So I'm kind of oversimplifying with that example, but that's what happens with, that's how forms and lookup tables are so powerful. Computing applications that don't control the input are a train wreck. Okay. Function syntax error. A function is defined, and when executed, a syntax error is displayed, including a pointer that appears at the end of the parentheses symbols. Choose the most likely cause of this error. Well, when you try to run that, it's probably going to bark at you because it's going to say, hey, a colon. When you're defining a function, the first thing you have to do, here's your clue. It's at the end of the parentheses symbols. If that colon is missing, if the colon character is missing at the end of the symbol, Python doesn't know that you are defining a function. It thinks you are calling a function. Does that make sense? Yes, no, maybe?
Yeah.
Yes.
Now, if the function lacks proper formatting, indentation, and spacing, then you'll get different kinds of errors, or you'll get nothing. But this error is very specific in terms of, that's why that last choice is not the case. All right. So this does happen, and it's actually happened to some of your classmates. You know, they said, hey, Kentop, I can't get my function to run. And it had to do with formatting. In some cases, if you use the tab key instead of deliberate spacing, that's the same each time. Python gets weird about indentation spacing. Alrighty. Moving right along, a multiple choice question reads, you notice that a relationship between two tables of Microsoft Access does not reflect a one-to-many relationship. However, it is quite certain a one-to-many relationship exists. It is also important to preserve the dependencies between database tables so that a record with related data in another table cannot be accidentally deleted. What actions do you take to remedy this problem? When you're building the tables and then you drag and drop between the tables to build the relationship, a little pop-up window occurs and you're supposed to check some boxes. Does everybody remember that in the solution that we performed? When you check the boxes
Yes.
and you enable referential integrity, what happens is that you change the relationship. Data in one table cannot be deleted accidentally. So what are we saying? Let's say that you have a customer record, but over here you have a purchase record for that customer. And you delete the customer record in the customer table. Well, now you have orphaned orders or purchase records, right? So you have order or purchases in the purchase table or order table. And when it goes back to the customer table, there is no such animal, right? So you don't have a customer in the customer table. The referential integrity checkbox is important because it helps establish this it helps anchor down this one-to-many, but it also keeps you from deleting records where you end up with orphaned data sets. And that's in the mix somewhere in your study guides or addendum. And if you're the first to email, or you say, I can't find any of that anywhere, then again, I'll pay, I'll post credit. I'll reward a bounty. Any questions so far? Acid data. Let's see if we can get to the end of these multiple choice, and then we'll get down to the multi-answer at the end. Okay. Acid data. A researcher must collect data from measurements of turbidity. Turbidity is a plain explanation of what turbidity is. Well, it has to do with water clarity. Do we have any environmental science students in our group today? By chance? Anybody? Yes, no, maybe? No, okay, no environmental. MMES students? Marine and environmental science? All right, never mind. A researcher must collect data from measurements of turbidity, water clarity that is collected from a sensor using real numbers, floating point. That means there's a decimal point. Select any items below that are not part of recommended practices for collecting data. Well, select any items that are part of recommended practices. An appropriate name for the input variable is real turbidity level. What about this name? What's wrong with naming turbidity T?
T can stand for anything, and it's not descriptive, so you kind of don't know what's, like I said, it could be referring to anything.
Excellent. Thank you. Yeah, it could stand for time, could stand for temperature. Yeah. Tensile strength, right? All right. Input values should be separated by the comma character. So, now I did see that students chose this one. What happens if you define the variable real turbidity level as an integer? What happens to part of your data? All right, so let's extend that question. My sensor is measuring water clarity. And let's say there's a scale that's used, I'm just pretending that there's a scale that measures water clarity and it has a decimal point in there. So let's say we have a water clarity of 2.4, right? 2.4. Everybody with me? Or let's make it 2.6. Let's make it even more interesting. 2.6 or 2.8. And I stow that data into an integer data type.
It's gonna come out as a whole number.
It's going to come out as a whole number, and is that going to preserve the integrity of your data?
No,
No, you lose the 0.8 or the 0.6 or the 0.4, whatever it is.
because you're using measurements, you're probably gonna get a decimal in there.
If it works at all, it'll store the whole number, but nothing that follows, if it works at all. So depending on how the code is written, you'll get errors. You can get errors where, and all right, so I know a lot of programmers that would argue that point, but yeah, depending on the context. In some cases, it won't work. In other cases, it will, but it'll only store the whole number. So that's why this cannot be an answer. Any questions about this item? Thank you for chiming in on that. All right. Example 1. Which access feature, the following relational algebra operator, is represented by this symbol? Which feature in Microsoft Access performs the same function as this relational algebra operator? It is the selection or not of given fields in the query design. So this looks like the symbol pi, but it's in relational algebra, that symbol performs the same function as a query option that either includes or excludes entire fields from the output. It's different from filtering. Filtering is when you say, okay, I want to see all Christiansted zip codes, and you filter for Christiansted zip codes. This database function or relational algebra operator says, okay, I don't want to see any zip codes. Just leave zip codes out of it. And those fields of the data table are excluded entirely or included entirely, right? Any questions about how that's different? The distinction between those two. Alrighty. Let's see. One-to-many. For a one-to-many relationship between two tables to work properly, the following is required. Another way to state this question is to say, to normalize data, right? A table structure so that records are uniquely identified and there are no duplicates. That is one requirement of data normalization to work properly. And one of the benefits of data normalization is that you can create one-to-one and one-to-many relationships between fields in the data tables. Any question about that answer? All right. Moving right along. Multiple data sets in a query. Did we do this one? True, false. In order for a query to yield data from multiple data sets or tables, it is not necessary for each of the tables to contain all of the fields and records required for the query if the tables are properly related. That is true. That's part of the magic of creating joins with SQL, structured query language. So essentially, you're able to stitch tables together where you don't have duplicate data, but you can still draw from all of the multiple data sets. I'm surprised this many students missed that one. So it is not necessary for each of the tables to contain all of the fields and records required for the query if the tables are properly related. Yeah, that is true. So maybe there's a different way to reword that statement. I'll look at that for the final attempt, okay? Ordering data import steps. We'll cover this one, and then in the time remaining, we'll cover the multiple answer at the end, unless anyone wants to see the rest of these. Order the steps taken to import CSV data files. What does CSV stand for? Anyone?
Comma separated values.
Comma separated values. Thank you very much. With headers in Microsoft Access to create a new database table. Number one, you select new data source from, and then select delimited versus fixed width, and then enable use of first row for field names, and then change the indexed option to yes, no duplicates, and then change primary key option to choose my. Essentially, if you follow along with the import steps in Access when you performed the solution, you'd be able to pick each of these in order. And I'm pretty sure this was a pain in the neck for students to navigate, but a good number of students got it right. Any questions about this item? Alrighty then. Does anyone want to see this question about tuples or the last three? About data type, proper function, database table relationships. If anyone wants to see any of these after we finish here, just stand by and stay in session. We'll close out the session after this. This is a multiple answer question, and it reads, with regard to qualitative analysis of experimental data. Notice it says qualitative instead of quantitative. And the use of relational algebra, the following database has been configured using Microsoft Access. What significant considerations or conclusions can you identify given the details shown in image A below? Select all that apply. Well, this is right out of the solution. So if you haven't done the solution yet, ouch, right? I'm going from the species lookup table and I'm dragging from this primary key to a foreign key here. Turtle species ID matches turtle species ID there. I can have more than one sighting with the same turtle species ID, right? Does everybody understand the difference between turtle species ID and turtle ID number? Like each species can have an identity number, but then you can have like individual turtles that have names, and each of them have an ID number. So the species, well, anyway, I just thought I would call that out because sometimes people get tied up about that. The items that should have been selected read, the turtle species ID shown in the sightings table is a foreign key. The sightings table is here, this is a foreign key. It's, there are, the same ID can be used over and over again. You could have 27 sightings of a leatherback turtle or a hawksbill turtle, right? So the species identity or ID number for leatherback or hawksbill could appear multiple times here. Whenever you see the infinity symbol, wherever you see the infinity symbol, that's a dead giveaway that this is the foreign exchange or foreign key, and this is the primary. Any questions about that? So think primary and think one and prime. Everybody got that? Might help. Duplicates of the turtle species ID are allowed in the sightings table. That is correct. The turtle species ID shown in the species lookup table is a primary key. Now, what about these other choices? Duplicates in the turtle species ID are allowed in the species lookup table. That is incorrect. Okay. We don't have duplicates in the lookup table. Both turtle species ID fields exhibit a one-to-one relationship, values and data types match. If it was one-to-one, it would show a straight line, or it would show 1 and 1. That's the symbol for infinity, which means many. Any questions about this item? Okay. Does anyone want to see these last questions? Any of these last questions here? Turtles present in either table, what data type, proper function, misfire, data table relationships. Would anyone care to see? I mean, most everybody got these correct. Okay. If you need to peel off because you have another class or a commute to catch, I understand. I'm going to go ahead and show this one and then we'll close because there were a few more students that missed this one. This multiple choice question reads, what you want to apply a relational algebra operator to return tuples present in either table. So you're finding duplicates. If a tuple is present in both tables, it means it's kind of like a duplicate. As if you were to append the records of one table to another. Well, okay, so they're related tuples. As if you were to append the records of one, oh no, as if you were to append the records of one table to another. Yeah. Which RA operator would you use to accomplish this purpose? It's called a union. In your textbook and in the study guide, it explains this in similar terms. Any questions about this item or? Okay, I'm going to go ahead and post the reconciliation. In module 3, I'll post this recording after I work some quick edits. Just in the interest of time and sanity, I'm going to take the part about the detail I showed you about macros. We're going to post that as a resource in module 4 to explain more.